Welcome to the last video in polynomials. Here we investigate the link between the roots of a polynomial and the coefficients. We will introduce new language in the form of Greek letters and use our algebraic skills to solve some difficult problems. We begin with quadratic equations. The general form of a quadratic equation is ax squared plus bx plus c equals 0, where the a, b and c are the integer coefficients of the x values. Dividing by a, we get the monic polynomial x squared plus b over ax plus c over a equals 0. Our coefficients are the fractions b over a and c over a. We're going to call the roots of our equation alpha and beta. By doing this, we can write our equation as x minus alpha times x minus beta equals 0. Expanding that out, we get x squared minus alpha x minus beta x plus alpha beta equals 0, and by factorizing, we get x squared minus alpha plus beta x plus alpha beta equals 0. This is the exact same as x squared minus the sum of our roots times x plus the product of our roots, which will equal 0. By equating our roots, we get alpha plus beta equals minus b on a, and alpha times beta is c on a. We're going to use this principle to find the roots of our quadratic equations. Now let's look at an example. Example 14 asks us to write a quadratic equation with roots that are the squares of the roots of 2x squared plus 3x plus 5 equals 0. Now, we could try and do this first without using what we are learning today, but we would have to find the roots using the quadratic formula so we can square them for our new equation. But unfortunately, we run into the problem that the arithmetic under the square root sign, which we call the discriminant, will give us a negative answer, which we cannot square root. So we will need to find a different method. We're going to call the roots of our given equation alpha and beta. This means that alpha plus beta will equal minus b on a. b is 3 and a is 2, so the sum of our roots will equal minus 3 on 2. Alpha times beta is given by c on a. The 5 is our c, the 2 is our a, and so we get 5 on 2. Now, we're going to try and write a new equation whose roots will be the squares of our given roots. So our new roots will be alpha squared and beta squared. This gives our new equation a form. Our new equation will be x squared minus the sum of our new roots plus the product of our roots, which will equal 0. Now, we know what alpha plus beta is, and we know what alpha beta is, but we don't know what alpha squared plus beta squared is, or what alpha squared times beta squared is. So we're going to have to try and rewrite our roots from our given equation so it says alpha squared and beta squared. So let's see how to do that. It's important to note that alpha squared plus beta squared does not just equal alpha plus beta all squared. In fact, if we were to square alpha plus beta, we would need to expand the two brackets out, and we would get alpha squared plus beta squared plus 2 alpha beta. Now, it's almost what we want. We want it to equal alpha squared plus beta squared, but we don't want to write the plus 2 alpha beta. So, what we do is we subtract the 2 alpha beta from both sides, and we get an expression for alpha squared plus beta squared in terms of alpha plus beta, which we know, and alpha beta, which we also know. This is a useful identity to commit to memory, because we will see alpha squared plus beta squared come up a few times, and you don't want to have to expand brackets out each time to get it. So now I'm going to replace alpha squared plus beta squared with my new identity. You'll notice it in blue. What I've also done in the line I'm working out is I've condensed the alpha squared beta squared into just an alpha beta all squared. While I don't have values for alpha squared and beta squared, I do have a value for alpha beta, which I can sub in. So now I sub into my equation my values for alpha plus beta and alpha beta. This simplifies to this polynomial, but we need to have the coefficients and constants to be integers. So we multiply throughout by 4 to get our final equation of 4x squared plus 11x plus 25 equals 0. This topic in polynomials will test your algebraic skills to the max. Our goal is to write our roots in terms of alpha plus beta or alpha beta because we can work with those forms in the equation. At this point, you should try the first question in your text that involves a quadratic. Check your answers with the back of your book or ask your teacher for help if you get stuck. Good luck.